All right, let's dive into something pretty wild today. AI that's so smart, it can actually build other AI. Now, for years, these systems have been total game changers, but they've also been a complete mystery. I mean, they give us these amazing results, but we have literally no idea how they get there. Well, that's all about to change. So let's just start with that question. Seriously, what if you had an AI that was basically an expert consultant? You could just hand it a problem, and it would automatically sift through all the possible tools, pick the perfect one, tune it up just right, and hand you back a solution. This isn't science fiction, folks. It's a real technology called automated machine learning, or AutoML for short. So, here's what we're going to cover. First, we'll dig into this black box problem with AI. Then, we'll see how a new approach is finally shining a light inside. We're going to talk about assembling an AI dream team, figure out when you actually need one, and finally, see how we can go from a black box to what you might call a glass box. Okay, so let's get right to the heart of it, this whole black box thing. Why is a technology that's so incredibly powerful also so, well, so mysterious? Think of AutoML like an expert AI manager. It knows every single algorithm out there, all the potential employees, and it automatically goes out, hires, and trains the absolute best one for whatever job you throw at it. It's a massive shortcut. And the difference is just staggering. I mean, what used to take a team of human experts months of painful trial and error can now get done in just a few hours with AutoML. It's completely opened up the field, putting all this power into the hands of people who, don't happen to have a PhD in data science. Okay, but here's that catch I mentioned. For all its incredible power, AutoML has always been a complete black box. It hands you this perfect, optimized solution, but it gives you zero explanation for its choices. We don't know why it chose one tool instead of another. This analogy just nails it. Imagine a chef serves you the best meal of your life. It's perfect. But when you ask for the recipe or even just what's in it, they just shrug and walk away. The result is fantastic, but the process? A total mystery. That's been AutoML. And look, this isn't just about curiosity. This is a huge flaw with real-world consequences. How can you trust a decision if you can't see the logic behind it? How do you fix something when you can't even see how it broke? And in really high-stakes fields like medicine or finance, this isn't just a small problem, it's a total deal-breaker. But this is where the story gets really interesting. Researchers have been working like crazy to crack this thing open and finally shine a light on what's going on inside that box. And they've come up with a new framework built to do just one thing: explain the choices these AutoML systems make. It's called META-XENSEMBLE, and its whole goal is to turn that opaque black box into a totally transparent glass box. So the way this framework explains things is by breaking them down into 4 layers. It looks at which algorithm was chosen, how it was tuned, and what the data looked like. But the real breakthrough, the part that's totally new, is that 4th layer you see there. It explains something no system has ever been able to explain before. So here's the breakdown. Layer 1 tells you why a certain tool was picked for the job. Layer 2 explains how that tool was fine-tuned. Layer 3 dives into the data itself, the raw ingredients, and shows how that shaped the whole strategy. And then finally, Layer 4 answers the most complicated question of all. Did the AI decide to go with a single expert, or did it build an entire team? In that 4th layer, that brings us to the most groundbreaking piece of this whole puzzle, explaining how, and more importantly, why, an AI decides to put together a dream team of algorithms. And this is the million-dollar question, isn't it? Why not just use the single best algorithm every time? Why would the system sometimes decide to combine a bunch of different ones to work together? This has been one of the biggest unanswered questions in AutoML. This is such a great way to think about it. An AI dream team, or an ensemble, technically, is like the Avengers, right? You don't call in the whole squad for a minor problem. You assemble the team for the really big, messy challenges where you need a bunch of different skills to win. And the key word there is diversity. So when exactly is a team the right call? Well, this is where the framework was really put through its paces, tested on all sorts of different problems to see when it would choose a team over a lone wolf. And the results were fascinating. Across 7 different datasets, the system decided a dream team was the way to go only about 28.6% of the time. This tells you something really important. The system is smart. It doesn't just build complex teams for no reason. It only does it when it's absolutely necessary.
And to really get its logic, let's look at two classic examples. On one side, we've got the credit G dataset, which is famously messy and complicated. On the other, we have breast cancer data, which is way cleaner, way more straightforward. So how does the AI handle these two totally different challenges?
Well, the contrast couldn't be clearer. For that messy credit data, the patterns were all over the place, so different algorithms came up with very different ideas. That's what high diversity means. The verdict? Assemble the dream team. But for the clean breast cancer data, the patterns were simple and linear, so all the algorithms pretty much agreed. The verdict fair? A single expert is all you need. And this wasn't just a one-off. When you look at the data visually, the pattern is just undeniable. Whenever the data was complex and nonlinear, the system almost always chose a team. But when the data was clean and linear, it never once built a team. And the explanation makes perfect sense. If all your experts think exactly the same way, you gain nothing by putting them all in a room together.
Okay, let's bring it all home and see how this all comes together to finally take AutoML out of the black box and put it into a transparent glass box.
This table really says it all. Standard AutoML systems, they give you nothing, just a big no down the line. But META-XENSEMBLE explains every single step. And most importantly, as you can see right there in that highlighted row, it's the first system to explain that final crucial decision, why a team was or wasn't chosen. So why does this matter so much? Well, for one, it means way more trust, because now you can actually check the AI's logic against your own know-how. It means debugging is way easier, because you can see if the problem was the data you used or the tool it picked. And maybe the most exciting part, it becomes a learning tool. You can actually learn core machine learning concepts just by watching how the AI thinks. This glass box approach is a huge leap forward in making AI something we can all understand and trust. And it leaves us with this one last exciting thought. Now that we've finally cracked this one open, what other AI black boxes should we be trying to open up next?